So using equations in standard form to sketch polynomial functions. So notice I should have written in standard form. So yesterday we were looking at factored form. Today it's in standard form. Remember, standard form just means written with the highest degree first in order to the lowest degree. And notice this one has a degree of nothing. So when you are doing this, if you look, you know automatically this is a fifth degree. So remember, odd functions either start low and end high. One end is going up, one end is going down, or it goes this direction. Even, so these are odds. Even, and I'm just going to draw it over here because this one's not even. Even, the end behavior either both go down or both go up based on that leading coefficient. So if you look, the leading coefficient is the number with the highest degree. So the number in front of x with the highest degree. So our leading coefficient is -1. Our degree is 5, so you know it's odd. So if the leading coefficient is a negative and it's 5, which is odd, it's going to be one of these two. Well, since it's negative, it's going to be this one. Okay. The other thing that I want you to know or remember is that the y-intercept on this, the y-intercept is always the constant, or the number at the very end that's adding or subtracting. Notice it doesn't have an x, so the y-intercept is -3, which just means if 0 was in for all of that, 0 to the 0 times 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 0 is just 0, plus 2 times 0 times 0 times 0, plus 3 times 0. So that would just be 0 plus 0 plus 0 plus -3 would just be -3. So remember, your y-intercept is always just that number adding or subtracting at the end. So if I wanted to sketch this graph, we know the y-intercept is at -3, so 1, 2, 3. The leading coefficient is -1, and it's an odd degree, so it's going to look something like this. Okay, I'm going to go ahead and just graph it in my calculator just to show you that I was correct. So we have -x to the 5th plus 2x cubed plus 3x minus 3. When I graph it, so again, remember, this is just the end behavior. We don't care what's happening in the middle because we're just talking about the end behavior. So yes, there is stuff that happens here, so I could fix it a little bit if I wanted to. Oops, that looks terrible. So when I sketch those just based on that information, I know, and there we go, I know I'm only looking at the end behavior. That's why we talk about end behavior, because you know that one end's up, one end's down. Since it's a negative leading coefficient, one end's going down, one end's, or the beginning is going down, and so is the end. It's just both parts, or all of it's decreasing. So this part right here, remember what we talked about yesterday? The degree of 5 tells us how many zeros we should have. That degree tells you there should be 5 zeros. We'll talk more about real zeros and complex zeros, but if you look, this graph on your calculator has 1, 2, and 3. So that's where the 1, the 2, and the 3. So if you didn't have your calculator, you at least got this part of it, where this is going down and this is going down. It's just this stuff in the middle. And remember, that's what we're talking about when we talk about short term. This is the short-term behavior, and this other part is the long-term or end behavior. Okay, so let's do another one. So if I have y equals negative 2x to the fourth plus 3x to the, squared minus 2x plus 2. Okay, our leading coefficient is negative 2. Our degree is 4, so it's even. So either both ends are going to go up or both are going to go down. Our y-intercept is 2. And we know that we'll probably have 4 zeros. So let's go ahead and sketch this. I'm going to use pencil, actually. So we have a y-intercept of 2. Now it's an even degree, so it's either going to be both up or both down for the end behavior. Move it over. So either both up or both down. Since it's a negative leading coefficient, it needs to be a down. So it's going to look like that. So we know end behaviors are going to look like that. They're both going to go down in the end. And we know it has to cross the y-axis at a positive 2. So I'm going to go ahead and type in this equation. So negative 2x to the fourth plus 3x squared minus 2x plus 2. Hit graph. So it looks like that. And of course, it's just a sketch. If you wanted to get exact points, you could always hit second graph and look at the table values. So negative 1 should be at 1, 2, 3, 4, 5. So it looks like I should have gone up a little bit higher. But it really, if I'm just looking for a sketch, or if I give you a graph and say go backwards and write the equation, which I'll do one of those in just a second, you would know that the y-intercept is 2, so you need to look for that piece. It's an even degree because both ends are going down, and it needs to have a negative leading coefficient because both ends are going down, and since both ends are going the same direction, it's positive. Okay, I'm going to go ahead and I just want to show you one in factored form. So if I had negative x plus 5 squared x minus 3. So I have a negative leading coefficient. I have a multiplicity of 2 and a multiplicity of 1. So multiplicity of 2 and 1 means that this is an odd 1, and both ends are going to go down because the leading coefficient is negative. So it's a negative. This has a multiplicity of 2. This has a multiplicity of 1 because there's just one of them. So let's go ahead and sketch it. So if I have an x that's at positive 5, or a factor that's at positive 5, remember it's always the opposite is where the 0 is at, so it would be at negative 5. 1, 2, 3, 4, 5. And it's a double, so you know it's going to bounce off. And then x minus 3, so plus 3, 1, 2, 3. Now we know this end has to go down, and this end is like this. So the end behavior is that this is coming down, and then this is going down because it's an odd with a leading coefficient. Now we know this is a double, so it's got to bounce off, and then it's going to have to go straight through there. So that's kind of what it's going to look like. We don't know all of that stuff, so I'm going to go ahead and hit graph. So negative x plus 5 squared x minus 3. So it should, yep, it did that. It bounced off, and then it comes back down. So again, the main thing I'm looking for anytime you have to graph these is that you can identify, okay, it's a double root or a multiplicity of 2, a double multiplicity, is that it's going to bounce off. We don't know what it's doing up here, and then we know it's going straight through. Okay, so that is what I'm looking for when you were talking about sketching graphs. I did have one more written down. I'm going to just go ahead and do it really quickly just because I want you to see it even. So if I have y equals, actually I'm just going to go ahead and just graph it. So if I have that, and then I have this. Okay, and I ask you, what's the leading coefficient? What's the degree? And then what's the y-intercept? So the leading coefficient, I want you to just decide, is it a positive number or a negative number? Well, since it's opening up, you know it's a negative number. Since the degree, you know it's going to have to be even. So since both ends are going up, it has to be even. Now, since there are only 2 zeros, it would have to be even, and it's probably a 2. Now, if it would have done like that, then it could have been a degree of 4, because remember, the number of zeros tell you the lowest degree that it could be. So 4 zeros tell you the lowest degree could be 4. Now the y-intercept is -2. So we have a negative leading coefficient, we have an even degree that's probably 2, and a y-intercept that's -2. So you can also be given the graph and it tell you to find those key features.